Hi guys, and welcome back to Aisha.Academy. So I've done the June 2017 higher papers 1, 2, and 3 for those of you that would like to check that out on the channel for Edexcel. So now I've done paper 1 for this year's foundation papers, the June 2017, but I'm just going to be going through the paper 2 now, and then the paper 3 should be online as well. Okay, let's go through this. Alright, so first one says simplify. So remember, simplify, you're collecting like terms. But in this scenario, you need to think about your bid mass, or if you learn it as bod mass, because we've got a minus and we've got an adding. So looking at bid mass, bod mass, we've got subtraction and we've got addition. So we can see that the A addition comes before the subtraction. So you need to do the 3p plus p, sorry, the minus 3p, because it has a negative in front, minus 3p plus 2p per, wow, can't even speak. Yeah, so minus 3p plus 2p, which would give you minus 2p, and then you need to do your 5p plus minus 2p. But if you have a positive and a negative next to each other, it becomes a negative. So that's 5p minus 2p, which should leave you with an answer of 3p. This is where they trick people out. Then for part B, you've got m cubed plus m cubed. So remember, whenever you're adding algebraic numbers together, you don't change the indices. They're going to remain the same. If it was a case of where you are multiplying them, then that's different. Then the indices would change. But no, you're just adding them together. So it's like, because you're adding together m cubed and another m cubed, your total would be 2m cubed. But let's say it was a multiplication question, so m cubed times m cubed, then the m, there will be no number added in front of the m, but the two powers would be added together, and then that would be n to the power of 6. So that's where some people would easily lose marks. So remember, it's just 2m cubed. Then again, another simplify, collect like terms. So there's only one number on its own, which is 10. So 10 is just going to be there. If we look at the C's, we've got plus 3C minus 7C. So 3C minus 7C, which would leave an answer of negative 4C. And then you've got plus 5D plus D, so that would be 6D. And that's your final answer. You cannot simplify that any further because they're all different terms. Remember, simplifying is just collecting terms that are alike. Okay, so if we look at question 2, it says write 56.78 correct to one significant figure. So the difference between decimal places and one significant figure is decimal places focuses on the numbers. So I'll put it as DC for short, no, decimal place, DP for short. So decimal place just focuses on the numbers after the place, so after the dot. Significant figures takes into account all the total numbers. So if you're saying to one significant figure, it wants you to have one number in total, and then the rest would be zeros in this scenario. So we've got 56.78. Well, the only number that I can think of that would round to correct to one significant figure would be 60. Because in the case of 60, the only number that's not zero in this is the 6. And then you've got 0 on the end. So 60. Okay, having a look at question 3, it says a teacher asks students in year 6 what type of transport they use to get to school. So it's asking what's the popular type of transport used by the boys. So having a look at the key, the boys are grey and the girls have the stripes. So we're looking at the grey rectangles. So the one with the highest grey rectangle is the walking. So the most popular one for boys is walking. Then it goes on to say 3 girls walk to school. So it says show this information on a dual bar chart. So what this means is dual means 2. So notice how each mode of transport has 2 bars. The only one that doesn't is the walking one. And so we need to put the information on the walking one based on what they just told us. So because they said 7 girls walk to school, we need to draw a bar up to the number 7 and down. And because the girls was represented by the stripes, we would do the same thing. And that's that done. Then it goes on to part C where it says more of the students get to school by car than bus. How many more? So we need to work out the total students that travel by car. So for the boys, there's 5 boys, and for the girls, there's 9. So total students by car is 5 plus 9, which is 14. And total by bus, there was 6 boys and 4 girls, so 6 plus 4, which is 10. So then to work out the difference to see how many more go by car, you would do the number that go by car, take away the number that go by bus, which is 4. And then part D of the same question says the number of students in year five. So if I zoom in here, it says the number of students in year five is the same as the number of students in year six. What is the total number of students in year five and year six? Well, if we have a look at the beginning of the question, this is why it's very important to read the question carefully. It says that this bar chart is showing the students in year six. So if we know that the number of students in year five is the same as the number of students in year six, we need to work out the number of students in year six. And to do that, we're going to add all the bars together. Because this paper is a calculator paper, to make your life 10 times easier, you can just stick all these numbers in your calculator. So if I zoom into the bar graph quickly, so we've worked out the number that go by car, which was 14. We worked out the bus because we just did it for the previous question. Boys that walk, 9. Girls that walk, 7, because they told us. Cyclists, so there's 4 boys that cycle, 1 girl that cycles. 2 boys go by other, 1 girl go by other. So total that walk is 16, total that cycle is 5, total of others is 3. So literally just put into your calculator 14 plus 10 plus 16 plus 5 plus 3, you should get an answer of 48. Then because we know that there's 48 students in year 6, there would also be 48 students in year 5. And so to add the total together, put into your calculator 48 plus 48, and you should get an answer of 96. All right, moving on to question 4. So question 4 gives us a bunch of fractions and it wants us to write an order of size. So the best way to compare fractions is you want them to all have the same denominator. So looking at all these numbers, it's the best number to make them all the same denominator of is 30 because they're all they're all factors of 30. So the 11 over 30 is not going to change. So the 2 over 5, to change it to have a denominator of 30, we're going to times both the top and the bottom by 6. That's going to change it to 12 over 30. Then the half, to change it to a denominator of 30, we're going to multiply the top and the bottom by 15. So we're changing to 15 over 30. And then the 7 over 15, multiply both the top and the bottom by 2. And now we change it to 14 over 30. So having a look at these, to write the smallest fraction first, you want to look at the fraction with the smallest numerator. So the one with the smallest numerator is the 11 over 30. So we're going to write that one first. Then the next smallest is 12 over 30. But because the original fraction was 2/5, write it as 2/5. Then the next one, the smallest, was the 14 over 30. But again, because it was originally 7 over 15, write it as 7 over 15. Then last but not least was the 15 over 30. But because it was originally a half, write it as a half. And this is literally how you'd write it. Literally just an order from smallest to largest. Okay, so having a look at question 5. So David sells CDs in a shop. So we've got a tally of the number of CDs he sells on Mondays, Tuesday, and Wednesday, and we've got it in a frequency table format as well. However, there seems to be something wrong with this because it says write down one thing wrong with the tally chart. So because there's something wrong with the tally chart, we're focusing on this column. So let's have a look. Monday, if we count at the total number of sticks, remember in a tally, if it's written like this, that's the same as 5 because you go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you always write it in bunches of 5. So having a look at Monday, we've got a total of 13 based on the tally. Tuesday has a total of 18 and Wednesday has a total of 8. So Wednesday is correct, Tuesday is correct, but Monday is incorrect. So in our answer, we say Monday has been added up wrong or incorrectly or something along those lines. Okay, so if we scroll down to the next part of that question, it goes on to say, write down one thing wrong with the pictogram. So here we've got Tuesday. So it says that each round circle of the pictogram represents 3 CDs. So it wants us to write down something wrong. Well, let's have a look at Tuesday. So Tuesday has 3 round circles in total. So it has 15. Wednesday, however, has 3 round circles, which was 6. Then it has half of a circle, which is 1.5. So Wednesday has a total of 7.5. It wants us to write down something that's wrong with this. Well, Tuesday seems fine because it's a whole number. However, if we look at Wednesday, it says that 7.5 CDs are sold, whereas you can't sell half a CD. So Wednesday must be wrong. Ignore the messy handwriting. As 7.5 CDs were sold, and you can't sell half of a CD. So I hope that makes sense too. Okay, so going on to question 6. Question 6, we are dealing with working out. So we've got 495 coins. Third of the coins are a pound. 124 of the coins are 50p, and the rest of them are 20p. We need to work out the total value of 495 coins. So where it confuses people is the numbers here is telling you how many of those coins you have. Total value means total amount of money you have in total. So for instance, if I have two £1 coins, my total value is £2. So in order to work out the total value, we need to work out how many of each coins there are first. So let's look at the £1 coins. So it says a third of 495 are £1 coins. So because this is a nice calculator paper, if you put into your calculator 495 divided by 3, that will give you a third. And that should give you an answer of 165. So you have 165 £1 coins. Then in terms of 50p coins, it's given us the number. We've got 124 of them. And then 20p coins is the rest. So in order to work out the rest, you need to do the total, which was 495, take away 165, take away 124. That should give you an answer of 226 20p coins. Now we need to work out the values. So if we've got 165 £1 coins, the total of £1 coins is £165. If we've got 124 50p coins, then remember 2 50p coins make a pound. So in order to work out the total, you would want to do 124 divided by 2, or times by 0.5. As here you times by 1 to work it out, here you would times by 0.5 because 50p is 0.5 of a pound. And either way, that would give you the same answer of £62. Then in your 20p coins, so again, you've got 206 of them, so you can either do 206 divided by 5, or if that does not resonate in your mind properly or make sense, then another way is doing the same tactic here, where here for the 50p you did times by 0.5, so for the 20p you do times by 0.2. So 206 times by 0.2, and that should give you an answer of £41 and 2 pence. Sorry, £41 and 20 pence. So if you now add that together, so the 165 plus 62 plus £41 and 20 pence would give you a total answer of £268 and 20 pence. That's the total value. Okay, so moving on to question 7. I've got a probability value in the description box below or in the link above. So it says the probability of a new fridge has a fault of 0.015. So we need to work on the probability that the fridge does not have a fault. So we know total probability adds up to 1. So if we know that the probability of having a fault is 0.015, then not having a fault would be 1 minus 0.015, which would leave you an answer, if you put that into your calculator, of 0.985. Okay, brill. So let's have a look at question 8. So question 8a, it says from the numbers in the list, write down a squared number. So we know a squared number is a number that can be square rooted and it would equal a whole number. So the only squared number here is 25. Key thing is just make sure you learn all your square numbers up to 10. Makes your life 10 times easier. And then from the numbers in the list, write down a number that is a multiple of 4, both 4 and 6. Well, if we have a look, so the numbers that are part of the 4 times table here is 24 and 48. And 28. Numbers here that are part of the 6 times tables is 24 and 24 only. So the answer to this then is going to be 24 because both of them are multiple of 24. Both of them have 24 as a multiple. Okay, so then it says write down all the prime numbers in the list. So remember, prime numbers are numbers that can only be divisible by 1 and itself. So having a look at this, 21 is not a prime number because it can be divided by 7 and 3 as well. 22 is not a prime number because it can be divided by 2, 11, so more than 1 in itself. 23 is a prime number. It can't be divided by anything else except itself and 1. 24 is not. Any of these even numbers are not prime numbers, just to make life easier. 25 is definitely not because we know it's a squared number, so it can be divided by 5. 27 is not as well because it can be divided by 3. But 29 is also a prime number. So the answers are 29 and 23. And you must write down both of them to get the mark because it says write down all the prime numbers in the list. Okay, let's have a look at question 9. So we've got 2 angles, a right angle, and it says find the value of x. So we know that the total degrees of a circle is 360 degrees. So this 360 degree is this box here. Remember, if you've got a box, it means 90 degrees plus the 3x plus the 2x. So 90 degrees plus 3x plus 2x. I'm just removing the degrees for calculation's sake, is equal to 360. So, because these are both like terms, that can be simplified to 5x. You just add them together. So 90 plus 5x is equal to 360. Take away 90 from both sides. You're left with 5x is equal to 270. And then to work out x, you would put into your calculator 270 divided by 5. And if you were to do that, you would be left with an answer of 54 degrees. So let's have a look at question 10. So question 10, Suha is going to go to buy 150 envelopes. So there's information about 2 envelope shops, letters to send in stationery world. So she wants to buy the cheapest one. So we need to figure out which shop would be cheaper for Suha to buy the envelopes from. So let's have a look at letters to send first. I'm going to abbreviate for L to S. Okay, here, so it says a pack of 25 envelopes is £3.49. So, because the total that she wants to buy is 150, I'm going to do 150 divided by 25. So I need to realize how many packs of 25 she needs to buy to make her total. And if you put that into your calculator, you should come up with an answer of 6. So we know that she needs to buy 6 packs of 25 in order to have a total of 150 envelopes. So if we do 6 times the price of a pack of 25, which is £3.49, put that into your calculator, you should get £20.94. Don't try and look for a pound sign in your calculator. It's just put into your calculator 3.49 times 6. So then that's the price from letters to send. And then from Stationery World, it says a pack of 10 envelopes is £2.10. But for every 2 packs you buy, you get 1 free. Which means that if someone was to buy 3 packs from Stationery World, you're paying for the price of 2. Because the other one is free. So 2 packs, the price of 2 packs would be £2.10 times 2. Put that into your calculator, that would be £4.20. So 3 packs, so at Stationery World, 3 packs is equal to £4.20. And for 3 packs, you get 30 envelopes. So to work out how many sets of 3 packs she needs, you would do 150 divided by 30, which would be 5. So then you would do 5 times the £4.20 and put that into your calculator, you would get £21. And the one that's cheapest is letter to send. So letter to send is cheaper. Not by much, but still cheaper, I guess. Okay. All right, let's have a look at question 11. Let me just zoom out so you can see the question clearly. So question 11 says you can use this graph to change between inches and centimeters, and it says change 74 centimeters into inches. So if I zoom in slightly, okay, so 74 centimeters, remember centimeters is here on the y-axis, so 74 would be here, so I would draw a line across from 74. Oh, line across from 74, obviously yours would be neater, and down, and that is hitting at around 29 inches. So that's literally it. Just make sure you draw across and draw down. So 29 inches. Okay. And then part B, it says Daniel's height is 6 feet 3 inches. 1 foot is equal to 12 inches. And it wants us to work out his height in centimeters. So before we can work out his height and use the unit conversion, we need to work out his total inches of his height. So he is 6 foot 3 inches. So because 1 foot is 12 inches, what we would need to do is we need to do the 6 times 12, which is 72, and then obviously plus the 3 inches, which is 75. You can work this out in your calculator if you struggle to work this out in your head. And so his total height is 75 inches. So now if we look at the graph for converting, where the problem is now is our graph goes up to 50, it doesn't extend down to 75. So what we can do is we can split up 75 into 50 centimeters and 25 centimeters. And by doing that, you can then use the graph to work out what 50 inches is equal to in centimeters, and what 25 inches is equal to in centimeters. So 50 inches, having a look at the graph, it hits there at a value of 127 centimeters. And then 25 inches hits the graph here at a value of going across 64 centimeters. So then use your calculator, add together 127 plus 64, and in your calculator you should get an answer of 191. Okay, having a look at question 12, literally with these questions where it says display on the calculator, I kid you not, just write this down exactly how it's written in the question on your calculator. So what I would do is I would press that fraction button on your calculator first, the box over the box. Then I would use the arrows to basically fill up the top bit. So then press the top arrow and then press the square root sign, and then obviously the square root sign would come up with the box inside, and then start filling it up and put in the 13.4 minus 1.5. Then press your arrow down to fill up the bottom one. So then put the bracket first, fill it up with 6.8 plus 0.06, close your bracket, then square all of that, and then your final answer should be 0.0733035,908. And if it says display all the figures, you display all the figures. You don't round it, you don't put it to any significant figures or decimal places. The whole thing. Okay. So having a look at question 13. So we've got shape A, and it says rotate shape A 90 degrees from the center O. So the center O is not O, the center O is here. So if we're rotating 90 degrees clockwise, we know a clock goes this way round. So it would rotate that way round. And the best way when it comes to rotation questions is if you have a look at a graph, graphs are split out into boxes, right? If we have a look, they form 90-degree angles. So if I know I have a shape in this box and it says rotate 90 degrees, then it's going to end up in that box. Not percent, degrees. clockwise. If it said 90 degrees anti-clockwise, then it would go into that box. So that's the best way of dealing with these types of questions. So in this scenario, it says rotate A clockwise. So I know A is going to end up in this part of the graph. So now because I actually need to rotate it now 90 degrees, rotating it would end up leaving a shape like this. So it'll go that way if it was rotated. So now I need to plot it on the right parts of the graph. So for it to be rotated 90 degrees clockwise, around the center O. So what we need to do is we need to measure the distance between each point of the graph and center O. So if we go from this point here to center O, that's like 3 boxes diagonally. So 90 degrees is going to end up 3 boxes diagonally here. So that would go there. Here it's gone across 2 boxes diagonally, which would be 2 boxes diagonally here. And here it's gone 4 boxes diagonally. So we 4 boxes diagonally here. So I've got that portion, and then you can kind of fill up the rest. So here it's gone across 2 boxes, 3 down. So then if you now rotate, that would be there. And then fill it up. So once you get a few points, it's quite easy. Obviously, in the exam, I wouldn't recommend drawing in a different color, draw it all in pencil. But I'm just showing you it in red to show what the actual shape is that I've drawn out. So this would be the new rotation of A. Okay, and then question B, it says describe the single transformation that maps B to C. So if we look at B to C, they look reflected. The size hasn't changed, the position hasn't changed. Size hasn't changed, so it's not an enlargement. Position hasn't changed, so it's not a rotation, but it has been reflected. So in reflections, you want to figure out what is the line that is our mirror. So it looks like the mirror is here. And the reason why I'm saying that is because equal distance apart. Because if you reflect something from a mirror, you would think that they're going to be same distance reflected. So if that is my mirror line, that is my y-axis. So in your answer, you would just simply say reflection in the y-axis, or you could put reflection in x equals 0, because anything on the y-axis, x is equal to 0, and anything on the x-axis, y is equal to 0. Okay, factorizing, which I have a video in the link above of factorizing and expanding. So it says factorize 5 minus 10m. So remember, factorizing for single brackets, you want to find the common factor. So the common factor between 5 and 10 is 5. So 5 would be on the outside of the bracket. Then we want to divide everything by 5. So 5 divided by 5 is 1. And then minus 10 divided by 5 is minus 2. And then m would just be there. And that's that final answer. So then moving on to part B, it says factorize fully this. So again, you want to find the common factor between 2 and 6, which is 2. But also they have letters in common as well. So they both have an A and they both at least have one B as well. So now I've done that. Then the next bit is to divide everything by my factor. So I've got 2a squared b divided by 2ab. So the 2's will cancel out, the b's would cancel out, and then a squared divided by a gives you an answer of a. And then the 6ab squared divided by 2ab, so 6 divided by 2 is 3. A divided by a cancels out, and then b squared divided by b is b. So that would be plus 3b. Okay, having a look at question 15. So question 15, it says write 4.7 times 10 to the minus 1 as an ordinary number. So this is on standard form, which I have a video in the description box below or in the link above. So how we would do this is, with standard form, the power tells you how many decimal places you should go back. So because it says minus 1, I know it's going to be a smaller number, so I'm just going to stick some zeros there. So because it's just one space, I know the new decimal place would be here. So I wouldn't even need the other zeros since now I know where it is. So the final answer would be 0.47. And then for part B, when it comes to multiplying standard forms, the key method is you want to multiply the two numbers in front together. So 2.4 times 9.5. Because it's a calculator paper, you could just literally put that into your calculator. And that should give you an answer of 22.8. Then 10 to the 3 times 10 to the 5. So remember, whenever you multiply two indices together, you add the powers. I mentioned that briefly earlier. So that would be 10 to the 8. And then you've got 22.8 times 10 to the 8. Last step is your first number in your standard form must range between 9 and 9.1 and 9.99. So we need to change this. So to change it to fit within that range, we're going to move forward one space. And whatever you move forward by, so if you move forward one space, you take one off the power. If you move back one space, you add one to the power. So that would leave a final answer of 2.28 times 10 to the times 10. Sorry, I just realized we moved back a space, not forward. So we add one to the power, so 10 to the 9. Okay. And then moving on to question 16. So it says ABC are 3 points on a map. So it says 1 centimeter represents 100 meters. Point T is 250 meters from point A, and point T is an equidistant, so equal distance from point B and point C. So on the map, show one possible position of point T. So point T to point A is 250 meters. So to work out what that would be in centimeters, you would do 250 divided by 100, and that should give you an answer of, so if you put that into your calculator, 2.5. So you know that distance is equal to 2.5 centimeters. So if A is 2.5 centimeters away from T, on this map, what you would need to do is you would draw a circle. So you would need your protractor. So let's say your protractor would show that, as a rough estimate, obviously, T is here as a distance of 2.5 centimeters. Use your protractor now to draw a nice circle. So obviously this is not drawn to scale at all. So now you've drawn your kind of nice-ish circle, and we know that the distance from B to C and T to C, B to T and T to C are both equidistant. You want to use your protractor now. So that would be like that, something like that, and then the opposite way around. So you're looking at where both of those points cross again. And by knowing where they both cross again, that is going to give you a line. You want to draw a line. I'm going to do that again. You want to draw a line across those 2 points. So that would now give you a line that is, would be equidistant from here to here and here to here. Yeah, I hope that made sense, because I know drawing it on a whiteboard is slightly different to in person. Okay, having a look at question 17. So probability, name our roles, biased dice 200 times. This question was actually on the higher paper as well. And you want to work out the number of times the dice will land on 1 or 3. So total probability adds up to 1. So to work out the probability of rolling on a 1, because we don't know that yet, you need to do 1 minus all the probabilities that are there at the moment. And using your calculator, that should give you an answer of 0.31. Then, because you're focusing on the number of times rolling on a 1 or a 3, add the probability of it rolling on a 1 plus the probability of it rolling on a 3, and that should give you 0.49. Then another number of times for probability is your total probability, which is 0.49, times the number of times. And so put that into your calculator and you should get an answer of 98. Okay, having a look at question 18, which was also in the higher paper as well. So question 18, you've got adults and children and you've got a ratio from 5 to 2. So it says each person either sits in the circle or in the stalls. So it's given us a fraction for the number of children in stalls and number of children in circle. And it wants us to, this says that there's 2,600 seats and it wants us to work out if more than 60% of the seats were taken or not. So if we work out 60% of 2,600, oh, too many zeros in our calculator. So by doing that, you can do 0.6 times 2,600 as a shortcut, or you can divide by 60 times 500. Either way, you'd get the right answer. It's 1,560. So we need to make sure that our answer, in order for this statement to be correct, our answer needs to be more, like of the total seats occupied, needs to be more than 1,560. So let's draw a quick table. So A for adults, C for children. So this is our people. And then for the seats occupied, you've got stalls or you've got the circle. I'm going to write that smaller. So stalls, circle. Okay, so number of children in the circle, it said 117. Then it says 3/4 of children in the stalls. So if 117 is equal to a quarter, we need to work out what 3/4 is. So that would be multiply that number by 3. And if you put that into your calculator, you should get 351. So then total number of children would be 351 plus 117. Into your calculator should give you 468. So then in terms of the adults, we know that the ratio from adults to children is a 5 to 2 ratio. So if we know that there's 468 children, to work out the number of adults to deal with ratios, which I've got a description in the link in below, if you need to recap, you need to work out what one part is. So to do that, you need to do 468 divided by 2, which would give you an answer, if you put that into your calculator, 234. And then times that by 5 to work out the number of adults. And doing that would leave you with an answer of 1,000. So times by 5, 2, 3, 4, times by 5, 1,170. So now add those two together because you've got 1,170 adults plus 468 children. Put that into your calculator, you would get an answer of 1,638, which is definitely more than 1,560. So yes, more than 60% of seats were occupied. Okay, let's scroll down to question 19. So in question 19, again, this was in the higher paper. So it wants us to draw on the centimeter grid the front elevation and side elevation. So if we have a look at this question, it says the front was this side and the side was this side. So let's look at the front first. So the front wants us to draw this part on the centimeter grid. It's given us the conversion. So the 2 meters here, if for every 2 centimeters, every 1 meter is 2 centimeters. So that side there would be 4 centimeters. And so here would be 4 centimeters, but half a meter would be 2 centimeters. So drawing that on a centimeter grid, each box is a centimeter. So going down there would be 4. Across would be 4. Because it was equal to, not 2 centimeters, sorry, half a meter would be equal to 1 centimeter. That would be there. And then that would be there. So then just so they know which one was front and side, they put front. And then to show the side elevation, so side elevation was this part, the rectangular part, and the top bit as well. And so because of that, to write down the answer for it, it would be, so this side here, because you're looking at kind of a side angle, you wouldn't be using the diagonal, is the full straight length looking at it from the side, you would have to consider this height, the total height as well. So that would be 4 centimeters. And then this part here is, you've got the height for that part there, which is 0.5 meters, which is 1 centimeter. 1 meter across is equal to 2 meters. Sorry, 2 centimeters. So drawing that on, it would be like the square. Let's zoom out. So it would be a square down of 4 centimeters and then across of 2 centimeters down, and then the line, and then the box down. And then that would literally be your answer. So that would be your side. Okay, and I hope that that also made sense. Alright, looking at question 20, again, this was in the higher paper. So for question 20, if we have a look at it, Ollie drove 56 kilometers from Liverpool to Manchester. So Liverpool to Manchester, I'll just put man and then to Sheffield. So for Liverpool to Manchester, it was 56 kilometers. From Manchester to Sheffield, it was 61. The speed from Liverpool to Manchester was 70 kilometers, but the total time from Manchester to Sheffield was 75 minutes, aka 1 hour and 15 minutes. So it wants us to work out the total average speed from Liverpool to Sheffield. So what we're going to do is speed equals distance divided by time. Here's the triangle to help you remember that. So in order to work out the speed, we need to do the total distance divided by the total time. So we know the total distance would be the 56 plus the 61, which is 117 kilometers. So then 117 kilometers. And in order to work out the total time, we don't know the time yet from Liverpool to Manchester, but we can work it out because we know the average speed. So to work out the time from Liverpool to Manchester, we would do distance of 56 divided by the speed, which was 70. So if you put into your calculator 56 divided by 70, that is 0.8. So then now we know that the time was 0.8. Remember that's 0.8 of an hour. So that's that part. And then from Manchester to Sheffield, we also need to convert it to hours because the unit for the speed is kilometers per hour. So then 75, divide that by 60, and that would give you the accurate answer as an hour, which would be 1.25. So then if you add 1.25 from the time from Manchester to Sheffield plus the 0.8 from Liverpool to Manchester, you should get a total time of 2.05 hours. So you're going to do 117 divided by your 2.05 hours, and that would give you an answer of 57.07317073, something like that in your calculator. But because it's the average speed, round it. So then to the nearest whole number, that would be 57. And if we have a look down again, this was in the high paper. So Janie drove from Barnsley to York, and the average speed from Barnsley to Leeds is 80 kilometers per hour, but the average speed from Leeds to York is 60 kilometers per hour. So Janie's saying that the average speed from Barnsley to York, you can just add the two speeds together and then work out a mean. So if Janie is correct, what does that tell you? Well, if Janie is correct, that means either the distance is the same or the time is the same. I'll just put the time must be the same. So in order for her to be correct, it's either the distances are the same or the times are the same. Because remember, we need to use both components of distance and time to work out speed. Okay, so having a look at question 21. So this is to do with similar shapes, which I have a link in the description below, and this was also in the higher paper. So I'm going to label the notes it's given us. So E to C was 8.1, D to C was 5.4, D to B was 2.6. So the first thing with similar shapes is we need to work out the scale factor. And to work out the scale factor, you need to compare the two shapes. So in this scenario, we've basically got a really big triangle, and we've got a really little triangle inside that are both two similar mathematical shapes. So these two lengths would be the same. These two lengths not would be the same, but they're similar because it's two similar shapes. So they're not exactly the same, they're similar. The only thing is they would probably be multiplied or divided by a certain number to be the same. So in order to do that, we need to find what? Well, we know that the big length for the big shape is 8.1, and for the little shape, so I'm going to draw it out because usually sometimes when it's within, some people get confused. So A, E, C is the first shape, and then B, D, C is the second shape. So 81, 8.1, 5.4, 2.6. So we can compare these two shapes. I hope that makes it clearer now. So to work out the scale factor, you need to divide one of the lengths by the other. So if you put into your calculator 8.1 divided by 5.4, you should get an answer of 1.5. So we know the scale factor is 1.5. So then therefore we've got BD and we're trying to work out A to E. So to work out A to E, you would need to times 2.6 times 1.5. Because to get from the little shape to the big shape, we worked out the scale factor is 1.5. So you need to multiply by 1.5. So use your calculator and do 2.6 times 1.5. You should get an answer of 3.9. And then if we go on to, everything's moved. Okay, if we go on to part B, it says A to C is 6.15 centimeters, and it wants us to work out the length A to B. So now we need to look at the proper big shape. Look at the proper big shape to help us work that out. Okay, so we're trying to work out this length. So if we know A to C is 6.15, we need to first of all work out B to C. And we can do that because to go from the big shape to the little shape, rather than times by 1.5, we would divide by 1.5. So if you put into your calculator 6.15 divided by 1.5, you should get an answer of 4.1. So we know that that's 4.1. Then if we know that's 4.1, then to work out A to B, we would do the 6.15 take away 4.1. And then your calculator, that should leave you an answer of 2.05 centimeters. Okay, moving on to question 2. Again, I think most of these last questions were in the higher paper. They tend to do that anyway with foundation paper. So the harder questions in the foundation paper tend to come up in the beginning of the higher paper. But anyways, moving on. This is on simple and compound interest for those of you that did not watch that video. And I have a link in the description box below on simple and compound interest to work them out. So we've got Anil who wants to invest £25,000 for 3 years in a bank. So which bank will give Anil the most interest at the end of the 3 years? So let's work out his interest in personal bank. So to work it out, you do 25,000 times by, so as the percentage, that it increases by 2% per year. So what you do to the rate is you divide the rate by 100. So put into your calculator 2 divided by 100, you should get 0.02 and add 1. So you always divide by 100, add 1. That'll be 1.02. Then your answer of that, because it's for 3 years, it would be to the power of 3. So now it's always to the power of how many years he's investing at that rate for. So it would be 25,000 times 1.02 to the power of 3. Put that into your calculator, you would come up with an answer of £26,530.20. And then for secure bank, so he initially for the first year has a rate of 4.3%. So we'll work out how much he has at the end of the first year, or actually we'll work out the rate as a 1 point something for the first year. So that'll be 4.3 divided by 100, which would be 0.043, add 1, which would be 1.043. And then for the rest of the years, it would be 0.9 divided by 100, add 1, which would be 1.009. So then you would still have your initial, which is 25,000. Because he only has a rate of 4.3% for 1 year, it would just be times by 1.043 to the power of 1, but anything to the power of 1 is itself. And then because his total is 3 years, then the 2 extra years of the 0.9%. So then that's going to be to the power of 2. So you've got the 1 year here and then the 2 years here. That's what makes your total of 3 years. So then times by 1.009 squared. Put that all into your calculator. That should leave you with an answer of £26,546.46. And the one that he ends up with the most money with is Secure Bank. So the answer is Secure Bank. Okay, having a look at question 23. So question 23, it says a number n is rounded to 2 decimal places. Write down an inequality of the error interval for n. So how we're going to do that is, basically, because it's been rounded, you either can round up a number or you round down a number. So if it was rounded up to 4.76, then the lowest number can be 4.755, because anything with 5 on the end rounds up. But then, for it to round down, it has to be less than 4.765. But then the reason why we're not putting less than or equal to, because it can't be equal to 4.765. Because if it was equal to 4.765, it would round up to 4.77. So that's how you would leave your final answer. Then we've got solving. So we've got a quadratic formula and we're solving, and it's not saying that our answer should be in decimal places of all significant figures. So we wouldn't use quadratic formula, but for foundation, you wouldn't need to know quadratic formula anyway. So solving, you need to know factorizing. So we're going to factorize. So 2 bracket factorizing, it's a quadratic equation. First term is x squared, so it's split to x and x. You're thinking of pairs of numbers that make 24 and have a difference of 5. So that would be 24 times 1. That's way too big of a difference, so no. 12 times 2, that's way too big of a difference, so no. 6 times 4, that's too little of a difference, so no. 3 times 8, that has a difference of 5. 8 minus 3 is 5. 3, yeah, so that works. So then, or minus 3 plus 8, because the reason why I'm saying with negatives is because you've got minus 24. So your two pairs are either going to be minus 3 times 8 or minus 8 times 3. Sorry, or let me not confuse you, or positive 3 times minus 8. So, to check which one works, you would have to test them both. So, minus 3 plus 8 gives us an answer of positive 5, which is what we want. Whereas 3 minus 8 gives us an answer of negative 5, which is what we don't want. So, it's going to be minus 3 in one bracket and plus 8 in the other bracket. It doesn't matter which one you put it in, purely because it's both starting with x's. If it was a case of where one of the bracket had 2x and the other one had x, then yes, it definitely matters which order you put it in. So because that's equal to 0, in that case, you basically want to make both of the brackets equal to 0. So x minus 3 is equal to 0, x plus 8 is equal to 0. And so if you rearrange that, x is equal to 3 and x is equal to minus 8. Or another shortcut is whatever you have in your brackets, if it's negative in your brackets, it's positive as a solution. Positive in the brackets is negative as a solution. So same number, flip signs. So then that would be your final answer. X is equal to 3 and x is equal to minus 8. Okay, last question of the page. If you made it this far, well done. Yep, so last question. So we have a arithmetic sequence. So it wants us to work out the nth term. So to work out the nth term, the first thing is you want to work out the difference between each of the terms in sequence. So they all have a difference of plus 5 because they're all being added on by 5 each time. So then that difference that's the same tells us what number is multiplied by n. So it will be 5n. Then we want to work out the first 3 terms of 5n. So when n is equal to 1, 2, and 3, then 5n would be equal to 5, 10, and 15. And then we want to subtract that away, or figure out how to get from 5n to whatever our missing part of the sequence is. So I'm going to write the first three terms. So to get from 5 to 3, we would minus 2. To get from 10 to 8, we minus 2. To get from 15 to 13, we also minus 2. So because they're all minus 2, final sequence is 5n minus 2. Then, looking at here, it says the nth term of a different sequence is 3n squared. Nathan says that the fourth term of the sequence is 144. Is Nathan right? So if the fourth term is 144, that means when n is equal to 4, you should get an answer of 144. Well, we need to substitute to work that out. So it's 3n squared. We're substituting n for n is 4. So that would be 3 times 4 squared. 4 squared is 16. 16 times 3. Again, you could just put this all in your calculator, to be honest, since it's calculator paper. So that would give you 448. So Nathan is wrong, because us working that out, we got an answer of 48, not 144. So Nathan is wrong. What Nathan probably did was he did 3 times 4, then squared that, because that would be 12 squared. And you can't do that because based on the law of BIDMAS or BODMAS, the I represent indices. Indices means your powers. And our I comes before our M. So you would need to work out the 4 squared first before you multiply it by 3, which is why Nathan is wrong. Well done for making it through to the end of this paper, guys. I hope this was useful. Stay tuned for more past paper content, and good luck with all your assessments, and thank you for watching.